So, in our previous class, am I audible? Okay. So, in our previous class, we have discussed about the gradients and summit curves and valley curves. Okay. So, basically, that are the basic of any vertical alignment. So, in this class, we'll discuss about the length of summit curve and valley curve, that how you will calculate the length. Now, first, if you consider the summit curve, in that case, that summit curve would be convexity upward. Okay. Now, if you consider the driving condition in the summit curve, in that case, if one vehicle is passing a summit curve, in that case, what will happen? That centrifugal force will be acting upward. Okay, where the weight of the vehicle would be acting downward in case of summit curve. So, for this reason, what will happen? That the weight of the vehicle, some portion of the weight of the vehicle, or some component of the weight of the vehicle will be nullified by the centrifugal force. So for this reason, the pressure, okay, exerted on the vehicle axle and tire would be minimum. For this reason, in the summit curve, the passenger will feel comfortable. Okay, so there are no comfort conditions or comfort related problems in the summit curve. Summit curve is always comfortable. And see, this is very important. You just remember the logic why summit curve is comfortable. Okay, now the main problem in the summit curve is your side distance. Okay, because of the convexity is upward, for this reason, the visibility of the driver ahead is hindered by the upward convexity. Okay, so in the summit curve, the main problem is side distance. So whenever you are designing a summit curve, you need to consider for the side distance. Now, there are different conditions for the side distance. Okay. And you know there are two basic side distance. One is stopping side distance and another one is overtaking side distance. So let us consider first for the stopping side distance. So whenever you are considering for the stopping side distance, two type of conditions may arise. Okay, so first condition is the length of the summit curve may be more than the stopping side distance, and second condition is length of the summit curve is lesser than the stopping side distance. Now, what you have to do whenever you are designing, first you need to consider that your length is more than the stopping side distance. In that case, you need to find out what would be the total length of your summit curve. And in the second case, you have to assume that the length of the summit curve is lesser than the stopping set distance, and in that case what would be the length of your summit curve. So similarly, for the overtaking side distance also you need to do the similar things. Now let us consider this. So you remember what is n? Capital N. N is the deviation angle. Okay. So this is the figure for the length of the summit curve. So basically this is your summit curve. Okay. Now in the summit curve, h1 is the height of the object, which you know that as 1.2 meter, and h2 is the height of the object from the pavement surface. Okay. And this h2 is considered as 0.5 meter, as you have remembered from your previous classes. Now n is the deviation angle. Deviation angle means the angle subtracted between the intersection of the two gradients. Suppose this is one gradient of plus n1, and this is another gradient with a value of minus n2. In that case your deviation angle would be n1 plus n2. How it is n1 plus n2? It is n1 minus minus of n2, that is equal to n1 plus n2. Okay, so in that summit curve your total length, so in that case also, as I have already discussed, you have to consider two situations. So first situation or case A is length of the summit curve is greater than the side distance. That is, you are assuming that whatever length you will calculate for the summit curve, that length is more than the stopping side distance. So if you consider this, in that case your final equation of the length of the summit curve is n s square divided by 4.4. This is your final equation, where L is length of the summit curve, n is deviation angle, and s is stopping side distance. Okay, now after calculating this, after calculating the length, if you found that whatever length you have calculated, that length is basically smaller than the stopping set distance, in that case what will happen, that whatever assumption you have taken in your first step, that assumption is incorrect. Okay, so you have to go for your second assumption. Okay, now what is the second assumption? That your length is lesser than stopping side distance. So if you consider the length of, of smaller than SHT, then your final equation would be L equal to 2s minus 4.4 divided by n, where s is the stopping side distance and n is the deviation angle. Okay, so this is the uh, length of the summit curve considering the stopping side distance. So let us solve one problem. In that case it would be easy for you to understand this theory. Now see, one question is there, a question is there, so it is needed to solve. So let us try this problem. A vertical summit curve is formed by n1 equal to 3% and n2 equal to minus 5%. So design the length of the summit curve for v equal to 80 kilometer per hour. So let's do the numerical. So first you find out what is the value of capital N. So your capital N would be 3 minus of 5, that is 8%. So this is your deviation angle. Are you getting my point? Okay. Now please calculate what is the stopping side distance. Calculate stopping side distance. Now calculate the stopping side distance. You remember the formula for the stopping side distance? So to calculate the stopping side distance, first convert the speed into meter per second. Okay. So if you convert 80 kilometers per hour, in that case it would be 80 into 1000 divided by 3600. So tell me what is the value? Please calculate the value. 22.22 meter. Now, what was the formula for the stopping side distance? That was Vt plus V square divided by 2 Gf. Okay, where T is, what is the value of T? You remember what is the value of T? And what was T? T was perception reaction time, and the value of T is 2.5 second. The value of G is 9.81 and the value of F is 0.35. So putting all these values, please calculate the stopping side distance. Please calculate the stopping side distance and get me the value. What is the value for this? 127.448. Okay, so you are getting around 128 meter. Now you know what is the value of your stopping side distance, that is the value of S. Now as you are designing the summit curve as per the stopping side distance consideration, so first you need to consider that your length is more than the stopping side distance. Okay, your length is more than stopping side distance. So considering this fact, first you need to calculate your length of the summit curve using this formula. So you write that first we assume that our length is more than SST. So write like that: assume L is more than SST. Okay, so in that consideration, your total L would be, write this formula, n square divided by 4.4. So from this, find out what is the value of L. So calculate the value of L. So did you calculate the value of S? Sorry, L. So your L would be, the deviation angle is 8 into 128 square divided by 4.4. Okay. One thing I have done one mistake. Here N would be in percentage 8%. So you have to consider that percentage value. Okay. Here N is 8%. So you have to consider this percentage value. If it is 8%, in that case it would be 0.08. Okay. Into 1 28 square divided by 4.4. That's your n is 8%. So you go 297.89 years. That is the value. Now see this value of your length of the summit curve is more than your stopping side distance. So whatever assumption you have made, that assumption is correct. So this is your answer. That is 297.8 meter. That is your length of the summit curve. Now, consider the situation if this value, if the value of the length, if from the first equation or from the first assumption, if it happens to come out like 120 meter or 100 meter, okay, in that case whatever assumption you have made, that assumption was incorrect. So in that case you have to go for the second case when L is smaller than SHT, and similarly you have to calculate the value. Okay, so is it clear? Okay. So similarly, if you consider for the overtaking side distance, so the first case you have to consider when L is greater than OST, and that is the formula. And secondly, you have to consider when L is lesser than OST, and in that case, that is your final formula. Okay. So these are the formula to determine the length of the summit curve. Now coming to the next point, length of the valley curve. So before starting the length of the valley curve, let us first discuss about the comfort condition in the valley curve. So valley curve would be like that. So whenever a vehicle is traveling to a valley curve, in that case the weight of the vehicle would be acting in the downward direction, and similarly the centrifugal force will also act downward. Okay, so this will create more pressure on the vehicle tires and axle, and for this reason, the passengers of the vehicle will face discomfort whenever traversing through a valley curve. Okay, so for this reason, whenever you are designing a valley curve, you need to consider for the comfort condition. Now another thing is in the length of the summit curve. As in the summit curve, you need to consider for the comfort, and here centrifugal force act very loudly or profoundly. In that case, what will happen that the entire valley curve is basically a transition curve. Okay, so entire valley curve is basically a transition curve. In case of summit curve, generally parabolic curve was considered, but in case of valley curve, the entire portion is transition curve. That means the radius of the valley curve is varying in nature. Okay, it varies from infinity to a particular radius, then again it will increase to infinity. Okay, so that is the main point of the valley curve. So, as comfort condition is main concern for the valley curve, because side distance is not considered in the valley curve, because in the valley curve adequate side distance is always present over there. Okay, so your valley curve is designed based on the comfort condition, and the length is given by this formula, that is L equal to 0.38 n V cube root. Okay, where V is in kilometer per hour. Remember, where V is in kilometer per hour, that is the speed of the vehicle or design speed, and n is the deviation angle in percentage values. Okay, so this is the primary condition for the length of the valley curve. Now sometimes you can also consider for the stopping side distance consideration, but first and foremost thing is your condition one is your comfort condition. After that you can check for the stopping side distance. So in that case, similarly there are two formulas, that is one is for L greater than SHT, and another one is where L is smaller than SHT. Okay, so for these two formulas that there, these are the formulas where N is the deviation angle, S is the stopping side distance. So I think this is clear to you, this portion. Okay. Is it visible the syllabus? Let us discuss about the syllabus. Syllabus is visible for your subject. Can you see the syllabus? Okay. So in the syllabus, we have already completed module 1. Module 1 is completed. That is highway development and planning, classification of road and road development, road project and highway alignment and project preparation. We have already completed this. So this is module 2. In the module 2, there is geometric design, where design of intersections problems, design of cross-section element, horizontal alignment, design of vertical alignment, all these things are covered. Now, design of intersection portion, this portion, that is basically included in the traffic engineering portion also, that is module 3. Okay, design of road intersection 3. So we'll complete this in this module 3. So we have already completed two modules, modules 1 and module 2, and I'll try to complete module 3 within this month. Okay, after that, After that, if the college reopens, in that case it would be better for this module, that is design of the pavement. So in this portion, design of the pavement, there are different design parameters are associated with it, and there are different code books like your structural design or building design. Okay, so it would be better if we continue this in our regular classrooms instead of these online classes. So let us hope for the best.